Hello everyone, and welcome to today's webinar, Docker Tips and Tricks. Before we get started, I'd like to go over a few items so you know how to participate in the event. You have joined the presentation audio using your computer speaker system by default. If you would prefer to join over the telephone, just select Phone Call in the audio panel and the dial-in information will be displayed. You will have the opportunity to submit text questions to our speaker and key Docker experts by typing your questions into the Questions section of the control panel. You may send in your questions at any time during the presentation to receive a typed response. We will also hold a Q&A session at the end of the presentation. Please note today's webinar is being recorded and you will receive a follow-up email to view the recording. I would now like to introduce our speaker, Docker Captain Brandon Mitchell from Boxboat Technologies. We will also have Docker Solutions Engineer Joe Calandro online answering your questions, so please post those in the Questions tab. Brandon, I will now turn things over to you.
Thank you, Melanie. So for everyone that didn't make it to Barcelona, this is a repeat of my talk that I gave in Barcelona. And the important link on this page here is the GitHub repo. If you check out the GitHub repo that I have out there, it has a presentation repo within there, and you can pull up this presentation, other presentations. So if I go too fast, feel free to check those out later on, and I'll have a link at the end of this presentation of those as well. So who am I? I am, as we were discussing, a solutions architect with Boxboat. I'm also a Docker captain, and the Docker captains are essentially the best way to phrase it is the community evangelist that like to spread the knowledge and teach other people about how Docker works and what's involved with Docker. And I got pulled into that program as a frequenter of Stack Overflow. I've got over 1,000 questions just on the Docker tag that I've answered so far, and still growing. It tends to be the thing that I do in my free time these days. So when I gave this talk in Barcelona, the first question I asked everybody was who there was a developer, and I can't see everybody's hands on this one, but when I asked there, it was a pretty much overwhelming majority of the audience was a developer in the group. And unfortunately, I can't see the hands from here, so I can't tell you who back there is raising their hands for me on this one. But the only downside if you aren't a developer is you may not get some of the corny jokes on this one. So I'll try to keep those to minimum this time. But from my side, I'm coming in from the operations side of the house. So the first question a lot of people have if they come into the operations side is with Docker, they fill up the hard drive. And the solution Docker has given us in the past for filling up the hard drive has been the Docker system prune command. They gave us this a few years ago, and it does exactly what it says it's going to do. It's going to remove all the stop containers, the build cache, stuff like that. It also doesn't do a few things, and I like to point those out to people when they run this command. Any stop containers, it'll delete, but it won't delete the running containers. And included in that, it's not going to delete the logs of those containers. And it's also not going to take out the tagged images and the volumes as well. Those are things that you can turn on if you want to. You can switch the defaults, but tends to be things you don't want to delete right away. But the key part about this one is to make sure that not only is it deleting the things that it tells you it's deleting, but you may not want to delete everything. So this is one of those commands that I tend to tell the audience to take with care. If you delete all the stop containers, that may include containers that were temporarily stopped that you didn't want to delete. If you delete your whole build cache on the server, if you have a large build environment, that means you're recreating a lot of image layers, reshipping those up to the registry server, re-downloading them to all of your Docker hosts that you're running these containers on. So that might be a bad thing as well. But if you still want to go this direction, the famous YOLO cry of the millennials, if you want to try this without concern of risk, you can run a command real simply, the Docker run command here that just says kick this command off in a loop. So there's a little shell script at the bottom there that just says in a while loop, every hour, kick off the Docker system prune command. And I'm running this from Docker that automatically restarts. It mounts the Docker socket so it has access to talk back to the Docker engine. And it runs this from the Docker image so it has access to the Docker command line. And so real simply, you can clean up all the stop containers, all the untagged images, stuff like that on any Docker host with a simple command. If you happen to be in Compose, or sorry, not Compose, but in Swarm mode with a lot of nodes across the cluster, you can kick this off. Very similar command. The volume mount is a little bit different. It's a mount syntax. And the scheduling of this is with a mode global. So that's the only other two differences there between the previous command. And this could clean up all of your containers, all of your untagged images and stuff like that across an entire swarm cluster with one command. But like I say, this is the YOLO option. It's kind of a high risk option there, but be aware that you could do it very easily from Docker. But what this didn't do was it didn't, excuse me, didn't clean up our logs. And so if you wanted to clean logs, by default, what Docker is going to give you is an unlimited log file for each container, and it's written to a JSON log driver. Those JSON logs, if you were to try to clean that from outside of the container, from outside of Docker itself, and just truncate the log file, you could potentially truncate that at the same time Docker's trying to write to it. You could see something, corruption that results from that, of a partial write of something in there. And because of that, I tend to recommend significantly against that one, because you don't want to corrupt the log file. That defeats the whole purpose of having logs. The good news about this is that the unlimited log files is just a default that Docker gives us. We can always change this default, and Docker gives us tools to do that. For a single container, you would do it with a couple options to a Docker container run command. It's just a Docker log op with a max size of 10 megs here I'm setting, and 3 is the number of files. And those two options, tweak them as you need to, and they interoperate quite simply. Is the first log file gets created with up to 10 megs. Once it fills that up, it's going to start a second log file with another 10 megs. Once it fills that one up, it's going to create a third log file of another 10 megs. So now you're up to 30 megs of logs for this one container. The second it writes that fourth log file to create more logs into that log that you have going in that machine, it's going to see that it's exceeded the max file. It's going to delete the first log file. And so you'll have, as a result, between 20 to 30 megs of logs per container when you have these options. And like I say, you can adjust this if you need to. Most of us, when we're writing logs in containers, or running containers in general, not running it as a one-off with a Docker container run. We're doing something more with Compose. And if you did in Compose, they have the same options over there. A little bit more verbose, but the same options. Myself, whenever I'm doing things in Compose, I have a lot more than just one service defined in a Compose file. And so this is where you get a very nice handy trick from Docker. It came out in release 3.4, the Compose file, where they introduced this little X- field at the top. Call them extension fields in Docker. And you can put anything you want to in an extension field, any syntax you want, as long as it's valid YAML syntax. And Docker will completely ignore it. So this lets you put things in there that maybe third-party tools are looking at inside your Compose file. In this case, all I'm doing is using some generic YAML syntax that's been in the YAML files from as far back as I know, that you can change, that you can basically copy and replay different variables in different parts of the file. So at the top, this ampersand default ops, that specifies that we're creating an anchor in YAML. And down below where I say star default ops, that creates an alias, and it's a reference to all the values set above. So when I use that alias down below, I'm just getting a copy of all those values above. It eliminates all the repetition within our YAML files. Very handy, works not just in the Docker YAML files, it works in any YAML file. So if you have Kubernetes or some other tools out there that have this kind of YAML syntax, you can reuse the same anchor and alias template in here. The other part I hadn't talked about yet was the two left arrows in there. That's also a YAML syntax for merging. So I'm merging together all the default options with some custom options for each service. So this lets us change these options per service and still have the defaults in there that I want to bring in, and you can override those defaults as well. Very powerful, very useful tool for me that I can use to eliminate a lot of repetition in my YAML files. And I use it for all kinds of stuff except logging. And the reason I don't do it for logging is because I do this in logging in a different place. I specify in the Docker's daemon JSON file just a one-liner in there that you specify the log-ops option in there and how big it is, how many files you want to create. This specifies that 20 or 30 megs of logs. This is per container. And as soon as you reload the Docker engine, you don't even have to restart it. You just need to reload it to have this change take effect. It will apply this change to every newly created container on this host. So it won't impact all the containers that already existed, but for every new container going forward, you're going to have these log options set on the container. So very handy to instantly change those settings for everything. And this is the way that I'd pretty much eliminate all of my full hard drives in my environments, at least. So this is very Linux specific. If you're coming from outside of Linux, if you have Docker for desktop on either Mac or Windows, they have the options there too. You can specify in the Mac side, there's a daemon tab in the preferences, click here to advance, and you can put any JSON syntax in there you want to. Similarly, Windows UI looks slightly different, but it's the same settings there. You go into the daemon, you change to the advanced tab, and you can specify any daemon options you want to in there as well. So anything that I specify in the rest of this talk where I'm pointing to that file, you can do it on the desktop versions just as easily. You're not isolated from it. So hopefully that would eliminate one key thing that people fill up on, need support from on the ops side. I also want to talk about networking next. So networking in Docker, the challenge that a lot of people have that I've seen, especially when I was at DockerCon in Barcelona, first thing I did was I plugged the laptop in, and the networks that Docker defined for some containers I was running internally was conflicting with the Wi-Fi network that was there in the conference. And immediately I couldn't talk outside of the laptop, it wouldn't connect to the network, all the stuff wasn't working the way I wanted to. And that's just because we have subnet collisions. If you have the same subnet in two different networks, you can't talk between the two. So to work around that, back in the day, originally Docker gave us a simple option in there, the BIP option they had in the daemon JSON file. This modifies the bridge network that Docker comes up with. That bridge network is specifying that subnet for any container that you don't specify a network for normally. So this is the default bridge, named bridge. Some people also know it as the Docker 0 network under the covers. So if you run a container without specifying a network, it's going to pick from this subnet. But most of us, if we're doing it in a compose file or if we're doing any other networking outside, you do a Docker network create and you want to connect multiple containers together on a network, you're using some other custom bridges, and that won't apply to this. So we had a new option that came out just in 1806 called default address pool. You can specify this in your daemon JSON file, and every time you create a network, a bridge network at least, on the Docker host from this point forward, it will pick the IP addresses from this subnet pool. And the /16 is making a class B network in there, so the whole 10.20.anything after that is from your overall pool in there. And the size after that specifies a subnet mask to give out slices of this pool. So it's going to give out class C subnets, 10.20.1, 10.20.2. It'll give out those subnets within this overall larger pool. And you see multiple pools in there specified. You can tie them together like that. So this very powerful came out in 1806. It's a great way to eliminate a lot of these subnet collisions if you can pick some subnets that you know at least in your own environment. I've seen this not just for laptops that are going from the coffee shop to the hotel to the office to the home, but I've also seen it in production environments where you have a Docker environment you spin up potentially off the network until it passes all the security checks, and then after it's passed all the security checks, they then connect it to the rest of the network, and I suddenly found out that the remote machines that we were finally connected to had the same network that Docker had picked. So very powerful, not just for the stuff you're doing for your laptop environments, but even for production. Find some subnets that you know you're not going to use anywhere else, pick those for Docker, and you'll avoid all the subnet collisions. So that helps out a lot if you're in a bridge network, but a lot of us are in swarm mode. And this came out just in 1809, so hot off the presses. When you initialize a swarm for the first time, you now have the option to specify these default address pools that Swarm gives out for the overlay networking itself. So not the local bridge network that applies to one Docker host, but the overlay networking that applies to multiple Docker hosts within a whole Swarm cluster. They're given out by the Swarm manager, so you specify these options when you initialize the Swarm manager. And these are pretty much the same options we had on the previous screen, just in a slightly different format. So you want to pass multiple subnets or multiple pools for the subnets to pick from, you just pass that option multiple times, and you specify the address mask as another option in there. So very powerful, eliminates a lot of the network conflicts that I've run into in the past. The other area I see a lot of people that need help with is network debugging. They're running an application that was outside of Docker before, they put it in Docker, and networking in Docker is a little bit different. You have the bridge and the overlay networks, or maybe they also see that the host and none network types are out there. They're trying to figure out which makes sense for them. And one option they tend to miss when they're trying to debug their containers and figure out what's going on with networking is that there's another network type out there. And is essentially you can configure one container to have the network namespace of another container out there. This, from anybody that knows Kubernetes, you've already seen this before. It is the same thing as pod networking, where you can have multiple containers on the same network namespace. And where that comes in very useful is that you can put up a little sidecar container to your application you're trying to debug. So say we're trying to debug the Nginx container here. we've given it a name called web-app. It's listening on port 9080 outside of Docker, and then inside the container, it's port 80 inside the container. And we're trying to figure out what's going wrong with it. Is it working properly? Is it receiving the traffic we're expecting it to? So I'm spinning up, in this case, the second line, the highlighted line here, second container that has the net option specified to container : and in this case, the web app, the name of the other container out there. That could also be a container ID. Specify that part of it. And now when we start this container up and we do any networking commands at all, we're in the same networking namespace. So in this case, I pick out the netshoot container, which has all kinds of network troubleshooting tools. If you haven't checked it out before, it's a great container to look at. The Docker staff member that put that one together back in the day, owe him more than a few beers. And in this case, I'm running the ss command. That is, for anybody that knows the netstat command, just the new version of netstat. But you can still run even netstat in this container. And that's going to tell me, with those options, all the listening ports inside the container, all the listening TCP ports. And if I run that, I see that port 80 is up and running, listening in this container. Well, it's listening that I can see in this container, but it's actually from another container. So right off the bat, we can see that we can spin up one container and use that to debug the networking in a different container altogether. Very powerful tool. It means our applications don't have to have all the network debugging utilities installed in that one container. We can just spin up a little sidecar, debug it, stop the sidecar, and we now have our still original application that was out there running, maybe minified, maybe it's just a single binary Go image out there without any other tooling included in it. We can still debug it without having to install any of that stuff in there. So very powerful tooling. And I want to point out that it's not just something like the ss command. If you had someone that wanted to do maybe a TCP dump and see all the traffic, watch that go across. In another window, if you spun up a little curl to check our WebSocket and see that we're actually talking to Nginx, when you come back and look at the TCP dump, you'll see all that traffic going across the network there. So whatever network command you want to run to debug things, you can do that within Docker, just using that -- net container : option there, and you can connect one container to the network namespace of another container. So immensely powerful trick that I've made a lot of use out of over my time in Docker. So next thing I want to point out here is analyzing layers. Layers, for people that look at Docker, is a bit of amorphous. I'm trying to think of the best term there. They hear the term, they kind of nod their head, they understand that Docker works in layers, and if you do something like a Docker inspect on image, they see a whole bunch of these little SHA-256 checksums. They're like, okay, I guess those are layers. They don't really fully understand what's going on. The first thing I want to point out when you look at this is I'm looking at an image that I built based off of the Jenkins LTS image. So if I compare my image to the Jenkins LTS image, you'll see that all those first layers in there, and there's a lot more in there. I just had to abbreviate for the slides here, but those layers are identical. So if I went back to that, you compare one to the other, it's the same set of layers up to a point, and then we start adding more layers on. What that's telling you is that those initial layers, they're immutable. You can't change them, you can't modify them. Every time you need to make a change to an image that you've extended, all you're doing is just adding more layers on. You're extending it, you're just creating more and more changes to it without modifying what was already there to begin with. But people, what they're looking for is more than just these little checksums. What they're looking for is, what command am I running inside the container to try to figure out what's going on in here, what's involved in each one of these layers. For that, Docker has a Docker image history command. You kick this off and you'll see each command that was run in there. You'll see I'm doing stuff not only in the original build, but I'm using BuildKit here, which we'll talk about in a few minutes. When you get down toward the bottom of this, those layers, the reason they're 6 weeks and 7 weeks old is they're the parent images that I pulled from and the parent to the parent image that it pulled from. So you're seeing stuff going all the way back to the very beginning of this Docker image build. Additionally, in there, you can see on the next to right column is the size. This kind of lets you hone in on any large layer to try to figure out where your size is going, significantly larger than what you were expecting. So in this case, if I see that 203 megabyte layer, I might want to dig into that a little bit deeper to understand, why is that layer growing so big? But the challenge from that point is, how do you dig in a step lower? How do you see what files are going into that layer? For that, the trick I like to pull out is doing a build. And for that, I'm not using BuildKit. I'm not sure if I could right now. I need to go back and look at some more BuildKit tooling to understand some of the underlying details of that one. But without using BuildKit, I run a build. I also turn off caching because I want this build to run from scratch all over again. And the key option I pass in here is -- rm equals false. When I pass that option in here, it's going to run this build again without the cache, and it's going to run each of the run commands inside of a little temporary container. That's the way Docker does every one of the builds. But at the end of that run command, normally it would do a cleanup of that container. And when I say --rm equals false, it doesn't clean that container up. It's going to leave that container around. It'll be sitting there potentially as a created state, but usually an exited state that you can look at later on from Docker, see what it was doing. But in addition to giving you more stuff that you need to do a Docker system prune on to clean up later on, you can do another command from Docker called Docker container diff. Pick any of those container IDs that was running as that earlier build, and what you'll get as the output from that is a list of every change to the file system that that container made. All of those changes, and you can run this not just on a build container, but any containers running in production. This is that container-specific read-write layer that you may have heard about when Docker's doing its different layered file systems. When you see that, the first column in there has little characters in front of it. The C says that it's changing something. If it changes a whole bunch of files, even if it's just changing some metadata on the files, you change a file owner or file permission, something like that, that does a full copy on write, so you get the full file over there. In the case of a directory, that's just some metadata for the directory. It's not going to take up too much space. But if you have a lot of large files in your file system and you see that C command or that C specification in front of the command there, that tells you that you're copying a lot of stuff from one layer to another layer, and that's causing your images to grow significantly larger than it needs to. The A lines in there, those are each of the files that got added to this layer. So when you add a new file into this, that's potentially good. You wanted to create something new for this image when you're building it. But if you're adding a lot more stuff than you expected, you can look at this and figure out what got added in there, and maybe you didn't need to include all the files that got included in there. The last option in there that I don't have in this slide is a D option, which specifies deleted. And if you delete something from a container, it's existed in a previous layer and you start up a container, you delete it, it doesn't actually delete that file out from any of the previous layers because they're immutable. All it does is set some metadata in the new layer going forward that says that file, if anybody tries to read it, no longer exists from the container perspective, but it's still there on the file system. When you push and pull images, it's still sent over the network. So the Ds to me tend to be bad. They tend to mean that you had a temporary file in the file system at one point and you try to clean it up, but you clean it up after it had already been written out to a layer. So try to avoid those as best I can. So some tips that I take away from this one is that if I'm creating a temporary file in one build step, I need to delete that file in the very same build step. And so I'll show you how to do that in a second here. But before I jump into that, any unexpected changes. So if you have a file permission change, a timestamp change on the file, that's going to trigger a whole copy on write. So be aware of that. It's not just going to change the metadata, it's the entire file that gets copied from one layer to the next layer. And the last tip that I'll get into in a few more slides here is try to do some of your dirty work in a multi-stage build. So like I say, I'll tell you that one in just a second here. But let's dig in first to how you can merge together multiple steps together. So if you write your first Docker file for the first time, you may design it looking something like this. And when you go looking on the internet, every other Docker file looks like the second example. And they're doing that bit that I was just describing where if you do a cleanup, so if I do that rm-rf at the end of this, you want to do it in the same run command, because when that run command finishes, that's when the layer gets written out to the file system. That's the end of the container, temporary container running. And now you have this file that's permanently in an immutable state in your image that you push out. So you want to do these cleanup commands like an rm at the end of the same layer where the file got created in. So that's very easily how you can merge together multiple run commands. Multi-stage builds, though, change that completely for us. We now have the option to have multiple from lines in this Docker file here. And throughout this Docker file build, as it's doing the first stage in there, all the changes in there. So we're pulling in a full JDK, we're doing an install of Maven, we're copying all of our source code, we're doing a Maven build, which might be pulling in a lot of dependencies and other stuff. None of that gets shipped out on the network. None of that gets packaged together as our final tagged image that we ship out in Docker. We don't push that up to the registry. We don't pull that down and run that in production. The part that we tag and ship is this last layer, assuming we tell Docker to build the last layer, which is the default. It's going to pull in just the JRE, so not the full JDK. And when we do this copy command, we specify to copy it from a previous layer. We pull in just the jar file, not all the source code, not the Maven install, not the other Maven dependencies that are pulled down to create the jar file, just the resulting jar file, and then we run it. So that's how we separate out, creating a lot of files in there with shipping a lot of files in our image. the cool part about this is that the next time we do another build, the Maven utilities already installed, they're visible in the Docker cache from the last time, so they don't have to get reinstalled a second time. So we have significantly reduced our build time, making the cache more efficient whilst also reducing the size of our resulting image simultaneously. So that's kind of a huge win-win, and it's the reason why the multi-stage builds really took off. So anybody that was trying that in the recent year or so, this has been a significant advantage for us. And so the multi-stage was pretty much as awesome as it got. And then about 6 months or so ago, Docker came out in San Francisco and said there's this cool new BuildKit tool that they're showing. If you look at a Docker file from BuildKit, it looks like it's got a few different things going on in there. And otherwise, it's the same Docker file. You can take your existing Docker files today and run them with BuildKit, and you'll see some improvements. But if you want to try to do some of the more advanced stuff, you're pulling in some different fields in there. The first one I want to specify here, and I'm pulling directly from the developer's repo. They have a Docker repo now for the Docker file, so you don't have to pull this stuff directly from the developer anymore. But that little pound line on the front looks like a comment, and it's got a syntax equal specification in there. And while it looks like a comment, it's not quite a comment. From Docker standpoint, it's called a parser directive. It tells Docker how it needs to parse this Docker file from BuildKit itself. That parser is an image that it pulls down. And so it will pull this image down dynamically and use that image to parse this Docker file. So we can change the parser for our Docker file just by changing this first line. Use this to do the build in production. Maybe all of our other Docker files are using the old stable and we have a new experimental feature we want to try. We can try that on just one build of just one microservice without impacting everything else in production. And you can upgrade this stuff at a different cadence, and we're upgrading our Docker engine completely. So the Docker engine may still be just the 1809 version where BuildKit first came into support. But if you try out 1903 when that gets released and you have some new features over there, you want to try those in production that's still on 1809, you can do that just by changing this little syntax line at the top, which changes the parser, which brings you some of these new features. So very powerful tool that decouples the upgrade of the Docker build process from the actual Docker engine we're running under the covers. So in that Docker file at the top, you see a tag on that says run mount. That kind of gives you the hint to the next few lines in there that I highlighted. The run has a few lines in there with a -- mount syntax. And the BuildKit includes some really cool features where you can do a mount of all kinds of stuff. And I picked two types on here. First type was a bind mount, and so I'm bind mounting the code in this case. And a bind mount in Linux is just saying take a directory from one location and mount it into a different location. So in this case, I'm taking from the source here is the build context that I'm pulling this out of. If you ever do a Docker build and the very last character you put in the build command line is a little single dot by itself, that's your current directory that you happen to be in. That directory gets shipped up to the Docker engine as your build context. When I'm running this mount with a bind syntax here, it can only see files in that build context that you shipped over as part of the Docker build. So kicks that off from the build context, so not anywhere else on the build host that you can look at, not anywhere else on your laptop. And also, if you were to try to write out from there, from inside of the Docker build back out to try to modify your local laptop environment or something like that, you wouldn't be able to do that because the build context is a separate area. So, this is a read-only way to pull in some files. I don't tend to do this for code so much, but if you had a very large read-only resource, the cool thing about this, if you're like processing some machine learning data or something like that, and you wanted to copy this into your build process as you're running the build, really cool way to pull it in there because we don't run a copy. And since you don't run a copy, that file only exists one time on the file system, not twice. So that dramatically reduces the build time since you don't have to copy a large data set into our container during the build process. So cool feature. The one I tend to use more than that though is the second line, that cache line. And here, if you're a Java developer at all, you're used to the .m2 directory. That's the Maven cache directory when you do a Maven build. Any other cache directory of any other build tool out there would work. So if you're a Go developer, there's the .cache directory under the user's home directory. Node.js, a lot of these other tools out there that pull in a lot of external dependencies, they each have their own cache directory. When you specify this in the BuildKit definition there for the mount, it will create effectively a name volume. That name volume, the next time you run a build later on, has the files in there from the previous time. So if I add one new dependency into here, normally I would have to pull down all the dependencies again to recreate that layer. But now since I've mounted this as a name volume external, first it doesn't get added into our image layers at all. So this is mounted external to image layers, it's an external mount. The second cool part is that the files, since they were there from the last time, if we add one new dependency, we only pull down that one new dependency. And we're not pulling down all of the other files in there and changes and stuff like that. We're not pulling down all the stuff we pulled down from the last build because they're already there from the previous time we ran this. So very powerful utility to speed up our builds. If that doesn't sell you on this, the next thing I want to show you is we can put secrets in there. So I know more than enough times I've seen online people asking the question, how can I include into my build the ability to go in and access private data? In this case, I'm pulling in something like a AWS credential so that I can access S3. And I'm running my commands in there that are accessing those credentials. Because I'm mounting it in there with the mount command, that never gets written to the image layers. So it's secure, it never gets shipped out to any registry no matter what. And from the build command, you just have the secret that you pass in there that just gets read by the secret within the Docker file. So you can pass this from your build environment to the Docker host that's running the build itself. So wherever you're running your build command to wherever your build host is. So from that very powerful way to pass credentials, a lot of people are looking at this for something like SSH. And you can use this for SSH if you need to pull from, say, a private Git repo. Some people have password protection on their SSH keys, though. If you have that, I'll throw this other option out there for you, which is that you run the SSH agent. You put in your passphrase in there to unlock the agent in there. And then when you run your build, you pass the SSH flag, which then goes into the Docker file, passes that SSH credential in as part of that run command, so that you can now access a private Git repo with password protected SSH key, pull this into your build. Very powerful stuff that I think people have been looking for a very long time. So hopefully that's selling people on Docker with the BuildKit option now. So if you want to do that, version 1809 introduced it. You just specify from the command line where you're doing your builds from, export a docker_buildkit equals 1. Once you specify that, you can run your builds just like any other time. You kick the Docker build command off, and it will use BuildKit instead of the original Docker build that it was doing before. So if you try that out and you like it a lot, all you have to do to make it the new default is to specify BuildKit true as a feature in the daemon.json file. And then every build you run from that point forward is now set by default to run. Okay, one other piece I want to specify in here for BuildKit is that it processes files a little bit differently. If you have a file that looks like this, where you have a multi-stage build and you have a test stage in there that runs a Maven test and maybe a developer image that gives them a bash prompt in there so they can go in and debug things, and then a release image at the bottom, stage at the bottom which runs a JDK. You could build each one of these. If you do a normal build, it will run all the way through the release. If you wanted to build a developer, you can specify the target to build just that one stage. And you may have a build process that's depending on this to run. And if you run it in BuildKit, the one thing I want to make sure you're aware of is that by default you're running that release as the last stage unless you tell it another stage to build. What BuildKit is going to do is it's going to look at that last stage. It's going to see that last 3 lines in there is highlighted, and it will immediately jump to that stage for the very beginning when it does its build. And it's going to get to the copy command, and it will see that it needs to pull in some layers from the build stage, and it will go back up and start building that. And it's multi-threaded. It can have a lot of stuff going on simultaneously. It's going to finish up that build. It's going to copy that file over. It's going to then set the command in there, tag that image, and it'll be done. The key piece out of this is that the test stage and the dev stage, those steps of this multi-stage build never ran. So if you have some dependencies in your build pipeline that says, hey, when we run through and do this, we want to make sure that the test stage always runs before we get something released in production, you're going to need to reconfigure a little bit in the environment to just specify that we do a build with a target of the test stage first. Once that passes, then do another build with the release target in there. So slightly different tooling, but just something to be aware of when you're using BuildKit, because it's so powerful, because it's looking at just the minimum stuff it needs to build. So a little different behavior there. Okay, so hopefully I sold you on BuildKit. The last little bit here I wanted to talk about, I had pretty much had all kinds of good content I could throw in there on talking Docker volumes, more particularly the Docker local volume driver. It's the default volume driver that you get out of the box. If you look at documentation out there, most of us just know that we specify, Docker volume create with a random name, whatever name you want to give it. That would create a volume local on the machine, and that volume you can use in all your containers, and it's kind of a black box. The volume ends up getting created in var-lib docker volumes directory somewhere in there, and you kind of ignore it from that perspective. But that's just the default. You can change the local volume driver to do pretty much anything you can do with the mount command. And so Docker's documentation will specify, here's how you can do an NFS mount, here's how you can do a ButterFS mount. And if you're in a compose file, this is what an NFS mount looks like. Real simple. No third-party drivers needed. Comes right out of the box, so you can do this. And the options in there you specify is the default local volume driver, the options to that driver, the type is NFS, the device down there at the third line in there under the driver ops is the remote path on the NFS server with a colon in front. That's kind of important for NFS, the way it does stuff. And the O field is the same O field you would pass to the mount command with all the options, say NFS version number, address for the remote NFS server, and the read-write. That's all going into the NFS mount command. Really, it's the mount syscall under the covers, which is why some of this looks a little bit different. People know the mount command itself, but otherwise, it's everything you're doing from the Linux command line to mount a file system. So this, as simple as it is, gives us the ability to run persistent data, some kind of persistent data for our containers in a swarm environment. If you have an HA NFS server, your containers can migrate from one swarm node to another swarm node to another swarm node and have the same data in the back end that it's accessing. So very powerful stuff when you need to have some containers moving throughout the swarm and still have your persistence. It's been out there for as long as I've known Docker. So I think a lot of people jump on third-party drivers not realizing how easy it is with the easy option to just use NFS for something and just get started. If you run into performance problems, then start looking at the more advanced options. But if you're in a cloud environment, something like AWS has EFS for the elastic file system there that you can specify your data is coming from, and those are coming right from NFS. So nothing you do, advanced to try to make this work in a cloud. The cloud vendors have NFS support right there out of the box, so you can just use this option. So that's real quick and easy on the NFS. You can do more than just that, though. You could specify an ext4 file system. Say you have a huge data set that you want to mount. You don't have to mount on the Docker host. You can mount directly into the container in a directory. Make it read-only and access it just like any other file system that you would on a Linux host out there. But I think a lot of people, we've used Docker for long enough. The next step in this is to say, hey, what if we wanted to mount an overlay file system? Well, an overlay file system is just a different file system type, different mount command you would run. And the key pieces to an overlay file system is on the -O field in there. So in that O field, there's lower directories and there's upper directories. The lower directories here are just like your image layers. They stack one on top of the other. And so you can have your read-only data set that you want to access within your volume. And then the upper directory is the same thing as the container's read-write layer that it has. So that gives you the ability to see the files in there that are potentially static, and per volume mount, be able to change those files from below. And whenever you make a change, it just does a copy and write, but every other read in there, those files aren't copied, so you still see the old files in there, so you're being very efficient in the storage. And if you made multiple volumes like this with different upper directories, but the same data underneath, you're kind of making that same image file system you see from Docker where different images extend in different ways. So you can have multiple containers mounting the same data, making their own changes to that data without stepping on each other's toes and without copying that data 5 different times. So kind of a powerful tool in there if you want to get advanced with Docker. The worker dir in there that it didn't talk about, that's just a temporary directory. Just needs to be an empty directory you give to the overlay driver. Real simple. You just pass that as an extra flag in there, just an extra empty directory. So very powerful stuff if you want to get advanced with Docker. The last field in here I wanted to specify, the last little volume mount command I wanted to talk about was a bind mount. Most of us know this with, if you look at the bottom of the slide there, the home user data : data. That's how we do most of our host mounts into a container. Specify the source directory and the target directory, and Docker it's done. It's just that easy. So this is a whole lot more lines to do almost the exact same thing. So you just make a name volume in there called bind test with a whole lot of options in there for a bind mount. and then you mount it into the container in this /test directory. So, if you see that, you're kind of probably scratching your head, well, why would you go through all those extra lines when the one-liner is just good enough for me? Well, the logic behind this is that you now have a name volume, and the name volume gives you one cool feature that you don't have with host volumes. And that is that Docker will initialize an empty directory for a name volume with the contents from the image in that directory. So whatever was in the test directory in the image gets copied into the home user test out on your host when you run this container for the first time, and that home user test directory is empty. Very powerful ability to take something from inside of your image, copy it out to the developer's workstation so that now they can modify it. And when they're running a container for the first time that gets pre-populated with whatever was in the image, they can change it around, restart their container, see those changes take effect immediately. So really cool tool to be able to initialize stuff that you had from name volumes, but now you can do it with a bind mount, just like you would have a host volume. So slightly different syntax, but it gives you another cool feature in there. But most of the developers, and I give this talk to a lot of developers out there, they're going the other direction. They've got the code checked on a laptop already. They've pulled it from Git or whatever they're pulling it from, and they run a command like this with the little $pwd to specify the current working directory, just mount that into my container. They'll kick that off in something like a Docker run command. And if you do that, I have one request for you, especially because you give these commands to other people, quote that option. If you give this to another developer that has a space in their path, well, first, shame on that other developer for having spaces in their paths, because that just always causes some error somewhere. But if you put quotes on there, that'll at least cause Docker to not break, because without the quotes around that option, Docker sees the path ending at that space and the volume mount's done, and then it's off to the rest of the command line and things would break. So just a quick PSA, put some quotes around that option. So that said, typically what happens for the developer is they're running a container out there that's based off an image that looks like this. They've got an OpenJDK, and the operations team has come in and said, you know what, the original image, we're going to add these 2 lines in here for you that creates a user inside the container to run all our commands as that user. They want to do that because they don't want to run containers as root in production. And I get that. That's a cool goal to have. So when they do that, you then go through in your container and say, let me specify how I want to run my container with some other options. I'm going to give it a different command to run, that I'm going to run a Maven build at the beginning of every time I start my container up, and I'm going to run the Java jar after that. So a little quick one-liner command with a little shell script bit of code in there. Use that so that every time they restart this, they get their code processed, because the volume mount in there specifies to mount the code into the container. And I'm also mounting the M2 directory in there as a name volume. That way that all the Maven dependencies that we pulled last time are still there. We're not pulling those multiple times. So trying to be a little more efficient. So we do this as a developer. This is pretty awesome. We just restart our code, and we now have the newest Java jar every time we want to run it up and running with our application. And we kick this off, and we would see something like this. That permission denied error I've seen so many times out in the field. And the reason behind this is that, quite simply, the UID of that application user we created inside the container is a different UID from the developer's workstation that the developer is running commands as. And Docker is just mapping these files into the container with the same UID. It's a bind mount, so the UIDs stay the same. So we have a challenge of how do we work around this from the Docker standpoint. And there are lots of options out there. There are lots of what I like to call bad options. The solutions I've seen out there, some people just say, well, run everything as root, forget running things as the app user. Or they say do a chmod 777 on your home directory, and that'll fix all the problems. Well, it'll fix some problems, and it'll create a whole lot of other problems for the security team that's pulling their hair out. But more importantly, Docker is still running these containers as a different user ID than what you are. Hopefully you're not running everything as root on your laptop. And so you'll see these files getting created from Docker with a different user ID still outside the container. So that's not a good option. Another option I've seen people give out is to adjust the UID of each developer's machine to match. That's a pain in the neck to try to change every developer's machine, but more commonly is to make every image that's run match the developer's machine. And so they're running a different image per developer because each developer has a different UID. So they have to recreate the image per developer, and that gets into the scenario that maybe we're not seeing exactly what production is seeing. So that's not a great solution either. And the last option that's in there is the UID GID to change it from the run or the compose line. When you do that, that doesn't change the files that are already in the image. So I'm coming into this from the operations side and say, you know what, we can always use a shell script to fix all our problems. And this shell script may not be the prettiest thing in the world, but I just want to throw it out there, just a word of caution for the developers. It's got a couple lines in there I want to point out. The old UID and the new UID at the top is looking at the two UIDs we have. The old UID is the UID of the user inside the container. That's the app user that's running inside the container. The new UID is our developer that we're pulling out from this volume mount. So the volume mounts is a file. We look at the permissions on that file, see what the UID is on that one, gather that. If those don't match, we kick this little user mod command off. That changes the user in the container. After we run that user mod command, if there are any files in there that didn't get picked up by that, we then do a find command that goes across the whole file system inside the container to fix the permissions, change the ownership and everything inside the container to match what's on our developer's machine. So I have this packaged together in a little script that I call fix perms. And then I copy that into the container from another base image that I have sitting out on the internet. And you can grab this little sudo bimage base image is out there for anybody to pull. The entry point that I kick off then just calls that script. And so that entry point looks like these couple lines, which just says call a little fix perm script to make the user in the group of the app, user in the app group match whatever the code directory is. And then I kick off this little exec gosu command real quick because I don't want to go too far on time here. That's just saying run whatever the command is as the new PID1 inside the container, whatever that process is in the container. The gosu part just includes an su command included in that exec command. So I do an exec that's dropping to the gosu command, and then the gosu command implicitly does an su plus an exec command that then runs whatever our command was. And our command is the same thing here, that little binsh with the maven build java jar. That's what's getting kicked off. And the user we're kicking off at in development only is changed to be root. And so this container will start up as root. It'll then run that gosu to drop down to the app user and run our application, but only after it's fixed all the UIDs and GIDs to match whatever our local developer laptop is. The end result of that is that the same image that we're running in production can run on all our developer machines, and the compose file for one developer looks like the same compose file for every developer. And all the code changes that are made on the developer's machine or anything that's getting output from the container are the same UID for that one developer. Very powerful stuff. So in production, the last piece in here I want to point out is that you would run the same image, you just take out a bunch of those options. You wouldn't do the volume mounts, you wouldn't run this as root, it would just run as the application. And this just works. So I've got a full example out there if you want to check it out. It's in the Docker base image. You can look at how Nginx does that in the container that I've created out there. And you can also pull this entire presentation. Everything I've talked about here is up in the GitHub repo under sudo bimage. Pull that down, check it out, run on your own browser. It's real easy, it just runs in a web browser. So if I went too fast for any of these details, you can pull those up later on. And if you have any questions afterwards, I'm going to start digging through the questions. I'm going to turn this over to Joe to talk a little bit about Enterprise Edition, and then I'll get back to the questions here in just a second. So Joe, over to you.
Thanks, Brandon. I'll give you a couple of the big questions. There was only a few. Great tips and tricks just for kind of Docker in general. A little commercial, if you will, on Docker Enterprise, the commercial offering from Docker. Helps customers, specifically enterprise customers, run this in production. We focus on any kind of application, on any infrastructure you want, centered around choice, agility, and security. Our portfolio of products span the desktop and all kind of server workloads you want. You run it on Windows or Linux in any cloud or in your data center with the reduction of risk in the fact that we're securing it. You can call Docker for support if you have trouble. We work with great partners like Boxboat, who have fantastic Docker captains and evangelists like Brandon, who know their stuff backwards and forwards. So thank you for your time.